Hello and welcome to this short video presentation of Organic Heat Exchanger's EnergiVault modes of operation, supported by real demonstration site data. My name is Jeff Barker, a Director at Organic Heat Exchangers. I will now share with you EnergiVault's modes of operation, supported by real demonstration data. This is a photograph of EnergiVault's demonstration system installed and operating at Quotient Sciences in Alnwick in the UK. On the left we can see the EnergiVault thermal battery, a store of approximately 1 megawatt hour of thermal energy stored at between -3 and -4 degrees C. On the right we can see the EnergiVault thermal battery charger, nominally 50 kilowatt refrigeration module that charges the store via crystallization of the working fluid. This simple schematic illustrates how EnergiVault's system is connected to a customer's chilled water circuit. So in this example, you can see a chilled water circuit delivering cooling to an office block using 2 chillers. It's interfaced with an EnergiVault system via a heat exchanger, which decouples the working fluid of the EnergiVault system from the working fluid of the customer system, thereby allowing EnergiVault to customize its storage temperature for optimum performance. In addition to the 3 example operational modes I'm about to show you, a fourth has also been demonstrated, although difficult to illustrate graphically. This is backup energy storage, where a proportion of EnergiVault's capacity is always held back in case of chiller-related or other supply problems. I'll first illustrate the 3 operational modes with simple graphs before showing real demonstration site data. The first example is where EnergiVault delivers the full chiller load. And we can see a simple demand curve here, which would be considerably lower than the capacity of the full load for a system. In this case, the chiller would run on par load relatively inefficiently. EnergiVault can displace the total of this load for a long period of time following the demand curve, allowing the chiller to effectively be switched off, avoiding that part load inefficient operation. In this second variant of the full facility cooling load, EnergiVault delivers the full load for a defined period, usually triggered by high electricity tariff, high distribution charge periods. This load shifting function is particularly valuable where clients with 2-unit or flexible electricity tariffs and pass-through duos or distribution charges can avoid such high costs. You can see here that the chiller switches off for this period and is replaced entirely by EnergiVault. In the second example, the demand exceeds the maximum chiller output for a period, resulting in an unmet demand, which would result in a building warming up. In this case, the EnergiVault delivers all the peak demand above the maximum chiller capacity. The third example shows where this peak demand is exceeded in an intermittent manner, illustrated by the cooling demand here. Conventional way to address this is through a second chiller, cycling and on part load, often operating inefficiently. In this case, EnergiVault can deliver all of that peak fluctuating load from its energy store, allowing the chiller or chillers to operate at their maximum and optimum efficiency. Now we will move on to real-time data to illustrate the 3 operational examples. The data for this is collected via EnergiVault's own cloud platform. All clients have access to the platform, which allows real-time control and monitoring, as well as the analysis I'm about to show you. Once logged in, live sites are shown on the screen. In this case, we can see the demonstration site at Quotient Sciences. Within the site, within the platform, you can access a wide range of data and analytics, including what we see here, which is a customer dashboard showing a wide range of data and metrics. Energy flows, power flows, temperatures, and the like are all monitored, visible, and controllable through the various elements in the dashboard. We can see here from the menu bar that we have accessed the analytics function and the chiller support dashboard. The first event from the real data is the full facility demand, and we can see here from the red curve that the chiller demand is replaced by the blue EnergiVault curve. The second trace shows the electricity demand on the chiller, going to zero for those periods where EnergiVault is delivering that full facility load. Finally, we can see the controls from the BMS where they're instructing both the chillers and EnergiVault to operate in order for that full load to be replaced. The second event illustrates the sustained peak, or our second example. We can see a sustained peak here running for a reasonable period of time, which is completely delivered by the EnergiVault discharge. And you can see from the second trace here that the chillers remain constant, again demonstrating that that peak is delivered by EnergiVault and that those chillers can be run at a steady state at their most optimum condition. The third event shows the data demonstrating EnergiVault providing intermittent peak facility cooling support. Again, in the second curve, you can see the chillers running in an optimum steady state condition, whilst the trace above shows the blue elements delivering EnergiVault peak support during those peak events. EnergiVault creates value in 5 different ways. Firstly, it can save money by shifting chiller electrical load from times of high tariff or peak distribution charges. Secondly, it can augment existing chiller capacity on stressed cooling systems and optimized part-loaded chillers. Thirdly, it can provide business resilience by providing backup cooling. Fourth, it can access network ancillary payments through various demand response programs. And finally, it can optimize on-site renewable generation, increasing utilization, avoiding excess export, and overall reducing energy and CO2 emissions. Thank you for watching. I hope you found this information useful, and please don't hesitate to reach out to us for more information. Thank you.